Let us now talk about this question. We are given an array of integers where all numbers appear even number of times except one number which appears odd number of times. We need to find the odd appearing number. For example, in this array, 4 appears 4 times, 5 appears 2 times, and 3 is the only number that appears 1 times, which is odd occurrence count. Right? Occurrence count for this is even, occurrence count for this is even. The only number which is odd occurring is 3. So we need to print this as an output. If we see this example, we have one number 7 which appears even number of times, and then there is a number that appears odd number of times. So we need to print 8 in this example. In an array, there can be many even occurring numbers, but there will be only one odd occurring number, and we need to find that odd occurring number in the given array. Now please pause this video and try to think of a solution for this problem. Let us talk about this naive solution first. In naive solution, we will traverse through all the elements. For every element, we will count how many times it appears. So you run a loop for traversing all the elements one by one, and for every element, you traverse the whole array and count how many times it appears, right? So you have j equal to 0, j smaller than n, j plus plus. If array j is equal to array I, then you do count plus plus. So you begin with 4, you see that count is 4. You come to 3, you see that count is 1. So when count becomes odd, you print that number, right? So that's all you need to do. The time complexity of the solution is clearly big O of n square. Can we solve this problem in big O of n time and big O of one auxiliary space? Let us now talk about big O of n solution. The idea is based on XOR operator. XOR operator has many interesting properties. For example, XOR of a number x with 0 is x. XOR of two numbers x and y is equal to XOR of same numbers in different order. So XOR operator is commutative. Associativity. XOR operator is also associative. So x XOR y XOR z is equal to x XOR y and z. So we use these properties to find the odd appearing number. One more interesting property is XOR of two same numbers is 0. So if you do XOR of x with itself, you will get 0. Now we use these properties to find the odd appearing number. And how do we use it? We simply do XOR of all numbers. The even appearing numbers, they will cancel out each other, right? When you do initialize your XOR as 0 and you do XOR of 0 with 4, your XOR will be something. Then you do XOR with 3, it will be something. Then you do XOR of with 4. So this 4 and 4, they'll cancel out with each other. And your XOR is going to be 3 again. When you do again with 4, you will have result as XOR of 3 and 4. When you do again with XOR with 4, your 4 and 4, they'll cancel out with each other and your XOR is going to be 3. Then you do XOR with 5, your result is going to be XOR of 3 and 5. Now again you do XOR with 5, so 5 and 5 will cancel out each other and your XOR is going to be 3. So that is how you get the output 3 with this approach. So the idea is simple, simply do XOR of all the elements. Let's write down the code. So it's a simple code. We have simply done XOR of all the numbers. Initializing result with 0 is important because of this property. If you do XOR of a number with 0, you get the same number. So your output for this case is going to be 3. Now let's slightly modify it. Let's say we have more occurrences of 3. Say you have 3 occurrences of 3. What will happen in this case? These two occurrences will cancel out each other. And in the result, you will have only 1 3. So that is why this approach works even for this case. Here is a variation question for the same question that we just discussed. Take a look at this question. We are given an array which has values in range from 1 to n plus 1. So if array size is 4, then you have elements in range from 1 to 5. And every element appears exactly once. So you have elements from range 1 to 5 and every element appears exactly once, and there are 4 elements. So one element from the range is definitely missing. We need to find that missing number. If you see this array, you have range as 1 to 4, sizes of array is 3. So one number is missing in the range from 1 to 4. And we are given that every element in the array is distinct. So the missing number is 2. If you see this array, there is one number missing, which is 4. We need to find that missing number. So please try it yourself. A hint for the solution, it's the same method that we have just discussed. And the idea is you simply do XOR of all the numbers and then you do XOR of the result with all the numbers from 1 to n plus 1. Right? So when you do XOR of all the numbers from 1 to n plus 1 and XOR of all the array numbers, you will have the number missing appearing exactly once in all these numbers. All the other numbers, they will appear 2 times because you are taking the array and you are taking the numbers from 1 to n plus 1. Right? So every number will appear 2 times because every number will appear in this and also in the range from 1 to n plus 1. There is only one number that will appear in the range from 1 to n plus 1. That's your answer. So if you do XOR of everything, right, numbers from 1 to n plus 1, so if you do XOR of all the numbers from range 1 to n plus 1 and your array numbers from array 0 to array n minus 1, you will see that all these numbers will appear twice. They appear here and they appear here. Except the missing number will appear only once. So that is your answer. There are many more variations of this question asked in interviews also. There can be one variation which is you are not given numbers from 1 to n plus 1. You are given numbers in a range and one number is missing. You can follow the same technique there. Also, there is a tougher question than this. There is a better question than this that we will discuss in the next video. And the question is finding 2 odd appearing numbers.